Okay, so now you have a tool bag full of all sorts of integration tools. So how you this is pretty much a summary of all the strategies that you have available to you before we move on to tables and numerical integration. So the first step, the first strategy is the kind of you expect. You better learn the 20 most important, the most important integrals that I give you at the very beginning of the journey. So learn the 20 most important integration formula. Next, okay, simplify the integrand. That's always a good advice. Next advice, try simple substitution. Before you go into any fancy substitution, let's sometimes, remember I gave you an example where we could have used the trig substitution, but turned out that a simple use substitution was enough. The next one, you want to classify the integrand to form. Now, what do I mean by that? For this, I need to go to this paper where I have more details. Form. So, the forms. We can look at product of sine and cosine. As well as tangent and cotangent, tangent and secant, and cotangent and cosecant. Okay. Now, another form, if you have rational function, what do you use? Rational function to partial fraction. Okay. If you have something like the nth root of ax plus b, this is actually, we just did it recently, then use rationalizing. Rationalize the damn thing. Okay. If you have product of power polynomial or any kind of algebraic times transcendental, use integration by part. Okay. So how should I put it in short? Product where only one of the factor is transcendental. Okay, so use integration by part. Just to give you a couple of examples what I mean by that, the integral of, let's say, x squared minus 1 times e to the x. Well, e to the x is transcendental, or the integral of x times cotangent x dx. Cotangent trigonometric function is transcendental. So use integration by part in this case. And then the last strategy is try again. Yeah, try again and go through the following. Try again what? What do we have here? Substitution, integration by part, manipulate the integrand. Sometimes you need to multiply by conjugate. Remember, we've done this as well. Use previous example. I just used a previous example a minute ago. Remember, when I had the denominator was x squared minus 4, I used previous example. And then, of course, you can use combination of the above. All right, so I'll give you a sequence of series of examples here. So let's see what I have here for you. Example 1. Let's evaluate the integral tangent cube d theta over cosine cube, okay? Probably after all the hard work you've been doing, maybe this is not that hard, but let's see. Am I done with page 4? Yes. All right, so move on to page 5. So let's see how we work this out, okay? So what we want to do, the integral of tangent cube of theta d theta over cosine cube. When you learn trig, you were told that a lot of times you need to apply or verify identities. It's good advice to write everything in terms of sine and cosine. Since the tangent is sine over cosine, you can simplify it to sine cube of theta d theta over cosine to the 6. And now, since we have odd power of the sine, remember, so we can break it down into the integral of sine squared times sine d theta d theta over cosine cube, cosine to the 6, and then the sine squared will be the 1 minus cosine squared, so you end up having 1 minus cosine squared of theta divided by cosine cube, cosine to the 6, keep saying that, sine theta d theta. And this is good because sine theta d theta, the antiderivative of sine theta d theta is the cosine. So now we're ready to perform a u substitution. We let, we'll let u equal cosine theta, and therefore du equal negative sine theta d theta. Okay, and so what we are looking at, instead of 1 minus u squared, I'm going to say that I equals the integral, instead of, because of the negative sign, it will be u squared minus 1 over u to the 6 du. Now this is easy. Break it down into u to the negative 4 minus u to the negative 6 du, and integrate. So it will be negative u to the negative 3 plus, because of the double negative, 1 wait a second, this will be 1/3. So over 3, and here we have u to the negative 5 over 5 plus c. Okay? Now, because this is 1 over u to the negative, if u is the cosine, u to the negative is the secant. You see that? Because what is u to the negative 3? 1 over u cubed, right? But u is the cosine. So really what we have is the secant. So we end up having 1/5 secant theta to the 5th minus 1/3 secant theta cubed plus c.